Hello, everybody. I am Mrs. Liberty A. Nobleza, Head Teacher 3 of Mataas na Paaralang Neptali A. Gonzalez. The best way to learn is by retaining the information given to us. And even though some of these are hard to process and retain, we are always here to provide you the support you need to get through the top lessons. Ladies and gentlemen, today we are going to determine the discriminant of the quadratic equation. But before that, let us first recall how to evaluate polynomials. Example, we have evaluate x squared minus 3y when x equals 4 and y equals 2. How to solve it? Of course, we need to substitute the given values for our variables x and y. X squared minus 3y will give us 4. Substitute 4 in the value of x. 4 squared minus 3 times 2, which is the value of y. Therefore, if we simplify it, 4 squared gives us 16, and 3 times 2 gives us 6. Therefore, 16 minus 6 is equals to 10. So, to evaluate x squared minus 3y, it gives us the value of 10. Okay, another example. Evaluate 2m plus 5np when m equals negative 4 and n equals 0 and p equals 6. Okay, to solve, 2m plus 5np is equals to 2 times negative 4, which is the value of m, and plus 5 times 0, the value of n, times 6, the value of p. Simplifying it, we get 2 times negative 4 gives us negative 8, plus 5 times 0 equals 0 times 6 equals 0. Therefore, simplifying it, negative 8 plus 0 is equals to negative 8. So the value of the polynomial 2m plus 5 times n times p is equals to negative 8. So you recall how do we evaluate polynomials. Okay, since we are going to get the discriminant or to find the discriminant of the quadratic equation and determine the characteristics or the nature of its discriminant, then we should know again, okay, recall the real number system. All numbers except complex numbers are real numbers. Remember? The real number system has the following 5 subsets. Counting objects gives the set of natural numbers. N is the symbol for natural numbers. And the natural numbers are 1, 2, 3, and so on. The set of natural numbers along with 0 represents the set of whole numbers. Whole numbers represent the symbol W. So the whole numbers have 0, 1, 2, 3, and so on. Okay, see the difference between the natural numbers and the whole numbers. Measurement of depths, temperatures, and others fall under the set of integers, which represent the symbol of C for integers. These are integers which have the positive and the negative sign, negative 3, negative 2, negative 1, 0, 1, 2, 3, and so on. If we cut a cake into equal pieces and then we may have a piece that represents a fraction, this is an element of the set of rational numbers. The symbol is Q for rational numbers, which means that when we talk of rational numbers, it is also a fraction. The numbers that are square roots of positive rational numbers, cube roots of rational numbers, and others such as the square root of 2 shows the set of irrational numbers. So irrational numbers do not give us an exact root. So we call it irrational numbers. Okay, these are more examples on real numbers. When we say real numbers, all the numbers belong to the real numbers. And rational numbers, we have here 5/6, 1.5, which means 1 and 5 tenths. 6 over 9, 3.78. 3 means 3 and 78 over 100s, and 8 over 3. So those are rational numbers. Okay? And integers, negative square root of square root of 4, I mean. Square root of 4 is an integers because when we extract the root of square root of 4, that is positive 4. It is a perfect square, okay? Then negative 3, 0, negative 8 over 2. Or we can say yes, negative 8 over 2 is negative 4, which is an integer. Whole numbers, you have 0, of course, as we said, start with 0. Negative, square root of 36, no negative, no negative. Square root of 36, okay? So the square root of 36 is 6, a perfect square. Then we have 12 and 9 over 3, which is equal to 3. Natural numbers are those which are 3, 70, 21. Okay, it says started with 1, the natural numbers, and we call all numbers as natural. Okay, and irrational numbers are square root of 5, negative square root of 2, square root of 31, negative square root of 6. So those are irrational numbers. Okay, now we are now ready to again get the discriminant of the quadratic equation. Okay, get the value of the discriminant or the discriminant of a quadratic equation. Let us have an example. X squared minus 4x plus 4 is equals to 0, where a is equals to 1, which represent, of course, the numerical coefficient of x squared. B is equals to negative 4, which represent the numerical coefficient of x. And 4c is the constant 4. Okay, so the discriminant of the quadratic equation b squared minus 4ac, when we substitute the value, it gives us b squared is negative 4 square minus 4 times 1, which is the value of a, and times 4, which is the value of c. Negative 4 square is equals to 16 minus 4 times 4 minus 4 times 1 times 4. So it is negative 16. Again, negative 4 times 1 is negative 4 times 4 is negative 16. Therefore, 16, simplifying it, 16 minus 16 gives a discriminant of 0. Since the value of b squared minus 4az is equals to 0, then the roots of the equation, the quadratic equation, are real, rational, and equal. Okay? Another example, x squared plus 7x plus 10 equals 0, where a is equals to 1, again, numerical coefficient of x squared. B is equal to 7, the numerical coefficient of x, and C, the constant, which is equals to 10. Okay? Discriminant b squared minus 4az is equals to, substituting it on the discriminant, then we have 7 square minus 4 times 1 times 10. 7 squared is 49. And negative 4 times 1 is negative 4 times 10 is equals to negative 40. Therefore, 49 minus 40 is equals to 9. Since the value of b squared minus 4az is greater than 0, which is 9, 9 is greater than 0, okay? And a perfect square, because when we get the root of 9, square root of 9 is equals to 3. Exactly 3. Then the roots of the quadratic equation are real, rational, and unequal. Okay, see the difference. Okay, next, x squared plus 6x plus 3 equals 0, where a is equals to 1, numerical coefficient of x squared, b is equals to 6, numerical coefficient of x, and the constant c is 3. Okay, Discriminant b squared minus 4az is equals to 6 squared minus 4 times 1 times 3. 6 squared is 36 minus 4 times 1, which is 4, and 4 times 3 is 12. Therefore, 36 minus 12 gives us 24. So the discriminant 24, which is the value of b squared minus 4ac, is greater than 0, but not a perfect square. Then the roots of the quadratic equation are real, irrational, and unequal. Okay? When we get the root of the 24, it is not a perfect square. That's why it is irrational. Okay? Another example, x squared plus 2x plus 5 is equals to 1. Where a is equals to 1, numerical coefficient of x squared. B is equals to 2, numerical coefficient of x. And c is equals to 5, the constant equals to 0. Okay? B squared minus 4ac. Okay, substituting the value, it gives us 2 squared minus 4 times 1 times 5. Okay, so 2 squared is 4 minus 4 times 1 times 5 gives us negative 20 or minus 20. Therefore, 4 minus 20 is equals to negative 16. Since the value of b squared minus 4ac is negative 16, it is less than 0. Therefore, we can say that the root has no real roots. Diba? Has no real roots because it is a negative number. Okay? Understand, everybody? Okay? I hope that each of you clear on this lesson. Thank you for your participation in today's learning session. And I am glad to have been able to give you clarity on this topic. Enjoy your learning journey. Take care always, and God bless you all.